Hello, today we're going to talk a little bit about the derivative and sort of how we can think about it on a very basic level. So first we want to understand what is the derivative. Well, if you have some function, say f of x, we'll take a basic one, like let's say you have f of x is equal to x squared, okay? It can be any function. Well, not just any function, but we'll cover that in a second. What we want to do is at some point we want to understand the slope at a point of a function. And so this, as you may know, is a tangent line. However, the derivative gives us the function of all the slopes at each point of the graph. Maybe it'll make a little more sense here in a second. So the formula, make sure you get this right. So the derivative of f of x at point A is denoted f prime of A is equal to the limit as h approaches 0 of f of x, I guess I should use a plus h minus f of a over, it's just the distance formula, and so the a's cancel out and you're going to have h left over. So I encourage you to pause the video and think about this, what this means. I'll show you graphically what we're doing. If you zoom in here, we'll say zoom in, then we see this point, and we're imagining, so this is the point A, f of A. Well, we're imagining that there's another point that is h, it'd be, there's another point super duper close, and that point's going to be a plus h, f of a plus h. And basically we're taking the difference here, and the limit as h approaches 0 as the points become infinitesimally close, basically is the idea. And yeah, and so that's like our basic idea of the derivative. Pause the video, take these notes, and then we're gonna just do a couple of examples. So I'll write f prime of A. All right. Now let's do some examples. Example 1. Let's do 1 over x. F of x is equal to 1 over x. Okay, so what we're going to do, we have 1 over x, and we're going to imagine, so it might be a good idea to draw the plot, which looks something like this, 1 over x, right? And we want to imagine some point A, some x value A, so this is a f of A, and then some point right next to it, a plus h. So using the formula here, we can say f prime of a is equal to limit of h, limit as h approaches 0, of f of a plus h minus f of a over h. Take it to the next line, we're going to have limit as h approaches 0 of, so f of a plus h is really 1 over a plus h because our function is 1 over x, right? And this is 1 over a. So we're going to have 1 over a plus h minus 1 over a over h. Okay, and so what we can do here is just some basic algebra stuff. So we're going to have 1 minus a plus h over, a minus a plus h over a plus h all over h. A's are going to cancel out, so we're just going to have h times 1 over a squared plus ah over h. These are going to cancel as well. I guess I'm going to write that. Which means that f prime of a, that's how we say derivative prime, that's what this means, is going to be equal to 1 over a squared. Now I think I'm missing, I am, because this is that, so a negative 1 over a squared. And so what we've just done here is we've said, okay, if I want to know the slope at any point, not the average slope, but the instantaneous slope, at any point on this function, other than x equals 0, as you can see, because the function's not defined there, then we can say that, well, I guess I'll keep using red. F prime of x is equal to negative 1 over x squared. So if I want to find the slope at 3, f prime of 3, so f of 3 is going to be equal to 1/3. So at 3 1/3, the slope is going to be equal to negative 1 over 9. And that checks out because we have a negative slope, and so that's one good example. Let's try another one. It's a different color, just for fun. That's a good example. Yeah. Example 2, we have f of x is equal to 4 minus x squared. Okay. So again, let's write down our formula. F prime of x, and we can use x or a, it doesn't really matter. A is just a specific point of x we're choosing, so whatever, this is like the general derivative, not just at a singular point. Derivative as a function, we would say. So we're going to take f of x plus h minus f of x over, what am I doing? Sorry, just zoned out there. Okay, so the next line we're going to have, this is 4 minus x squared, and this is, x plus h squared, and this is just 4 minus x squared. So we're going to have 4 minus x squared plus 2xh plus h squared minus 4 and then plus x squared. All right, so take a moment to check that algebra, make sure it's right. And that's all over h. And of course, I always forget to write this. F prime of x is equal to limit as h approaches 0. Sorry. Okay. Next line. Let's see here. So 4 minus 4. So those are going to cancel. 4 minus 4. Negative x squared plus x squared. Those are going to cancel. We're going to have, let's see here. Oh, something's not right. What did I do wrong? That's what I did wrong. This is going to be minus and minus. Okay, there we go. Maybe that's what I did wrong. We'll find out. So we're now going to have limit as h approaches 0 of negative 2x. In fact, we'll pull the h out. So h, negative 2x minus h. That cancels out, right? And so we're going to have limit as h approaches 0 of negative 2x minus h, which of course is just equal to negative 2x. And this is correct. All right. With that second example done, the video is going to end here. The next video I do on derivatives is going to cover some common derivative rules as well as maybe some trigonometric derivatives. Thanks, like and subscribe. Bye.